All right, everybody, we might as well go ahead and get started, even though not everybody is here, probably because they are currently accumulating late points for their projects. So, all right, we'll talk about this. You can talk about this later, okay? Let's talk about some new stuff. Hi, everybody. How are you all doing today? Are you enjoying the snow? All right, so how was Project 3? Everybody here pretty much got done? Did you all learn a lot? Good. I'm glad. So some classes when I give Project 3, I actually give you the functions and tell you what functions to write. Other times I let you write your own functions. I felt you needed a little confidence boost, so you got to write your own functions. That made the project a little bit harder. However, the next project, because we're a little behind, I'm making easier. It should be posted later tonight, and I will give you more code to work from this time. Okay. Let's see what's next. Okay, so I would like to tell you an amusing programming story, because now you should be capable of understanding it. One of my colleagues, a guy named Mark Maloof, hi Mark, because he's going to watch this video later on after I send it to him to let him know I'm publicly ridiculing him. I talked to him the other day, and he had been working on some code, and he was implementing this machine learning algorithm, which, you give it a bunch of data, and it tries to figure out the data and learn from the data you give it. That's the brief explanation. And his program was not working. It just wasn't working. And he knew the algorithm. He knew what he should be coding, but it wasn't working. So he rewrote it. He was actually writing it in C and C++. And so he rewrote it so it worked in a program called MATLAB. Anybody use MATLAB? MATLAB is very powerful, but very slow. So he wrote it in that, and it worked right away. And it drove him crazy. And for 2 days, he kept going back and forth trying to figure out why his C program wasn't working. He changed a whole bunch of things. Now, I would like to see if anybody here can guess what the problem was. Yes? He did not apparently use global variables, for I mocked him for that. Anyone else? Yes? He was probably C+, like halfway between C and C++, knowing him. The C++ string to a C string would be a good guess. My guess when I talked to him was that he messed up integer division, and he was doing integer division when he should have been doing floating point division. The answer is actually on the screen. What is this? The conditional operator. What did I tell you about the conditional operator? Never use it. And what happened is he used the conditional operator, and the conditional operator is this, true or false, and he put false then true. So he ended up switching. He ended up switching which was true and which was false. And as soon as he flipped those around, after 2 days, his program worked. Okay? So I love it when, it's like rare that this happens, but I love it when I have two things. I love it when I can mock Professor Maloof, because he's a good friend and I enjoy that. And I also love it when things that I show you in class come to pass and you're there. So our condolences to Professor Maloof for his 2 lost days. Just don't use the conditional operator, just use an if statement. It makes your code longer, but it's a lot clearer. All right, so last time we talked about scope. What is scope? Do you have an informal definition of scope? Sir? Yes, so the scope is where variables are defined and where you can actually use them. So if you define a variable and it's global, you can use it anywhere. If you define it inside a function, it has local scope. You define it inside a loop, it has that scope. So I brought a little practice problem along so that we could do a little bit of practice problems. If you would pass these around. And just you can either sit there in silence and do it by yourself, or you can partner up. I always like doing the partner thing. You all seem to like the sitting in silence thing, so it's up to you. You can choose. Let me just pass these around. I need to keep one for myself, and then the others I'll hand up. You're welcome. Extras. So go ahead, we're going to take like 5 minutes and do this, and we'll do it up on the board. Man, so many people aren't here today. Quite shocking. Yes? Yes, scope is essentially where a variable is valid, right? like which variable is used in a particular section of code. Most local scope wins. Yep. Given a choice between many variables of the same name, most local scope wins. Yeah, yeah, absolutely. Yep. Question? Oh, you ready to volunteer the answer? Because you want some candy? All right. So we have a volunteer. You all ready to go through this and see how it works? Go ahead.
So we'll start it in main.
Yep.
So you come to the first cout
Okay.
statement.
And I'm going to echo you just so it gets on the recording. So you started at main.
Yeah, and so your first cout statement is
Whoa, whoa, whoa. You're jumping ahead to the cout statement. What happens next?
in main you set I equal to 9.
So we set I equal to 9. Do we have any other i's around?
Yeah, you have a global constant I of
Okay. So we have a global constant I, which is
I equals
10. Is this evil or is this okay? Why is it okay? Because it's constant. Yes. Global variables are. All right. So we have a constant. We have main. We have I equals 9. We see out I. And which one does this print out?
It should print out I equal to 9.
It should print out I equal to 9. Okay. Then we go here.
Yeah, so you jump into the for loop,
Uh huh.
and so you have I again, but it's a different I because it's declared in a for loop.
Okay. So we're in the for loop. We have a different I.
And so when
Okay, so for the first iteration of loop, I is 0 and it calls j of 0. So we go down to j.
Right. And so the first thing that J does is call K.
J calls k. Go down to k.
And K will see out I, but this is the global constant I because no other I.
Okay, so we reach k and we have I here and it's the global constant I. Why isn't it the parameter I from j? Because it's not in scope. Yeah, it wasn't passed, and the only I we have is the global one. So it prints out. Okay.
And so then after it has completed the function K,
Uh-huh.
it'll then print out the I value which was passed from the for loop. So it'll print out
Yep.
0 the first time.
So after function k, it returns to j. It prints out, see how it's I here. This I was actually the one that was passed in, so it prints out 0. Then it returns, and it goes back to the for loop.
Right. And so it'll iterate the for loop again.
Uh-huh. And next iteration, I is 1.
Right. And so you get 10 and then 1.
So it jumps to k prints 10, come back to j is 1, it prints 1.
Right. And then it'll do the iteration one more time.
Uh-huh.
So you get 10 and then 2.
Yep. Okay, so it does it one more time. We get 10, then 2.
So you're done with your for loop at that point.
We exit the for loop.
And you now are calling J one more time. And it's
Uh-huh.
passing the value of I equals to 9.
Okay, now we call with this I. This is the most local I is 9, so it calls j with 9.
Right. And then you call function K.
Call function k, prints out 10, goes back, prints out 9, done, return 0. So it should be like 10, 0, 10, 1, 10, 2.
9, 10, 0, 10, 1, 10.
All right, let's see if that's right. Everybody think that's right? Yay, round of applause. Okay, just a little practice problem, so Milky Way. All right, so that's just a practice problem for scope. We can keep that for later, like, I don't know, when we ever use that again. Like on an exam, that would be great. All right, so we did the practice problem, and that worked out fine. Now we're going to switch to a new topic, okay? A new topic. Throughout the semester, we have on occasion encountered remnants of the C language, right? C++ is built on C, and we've encountered some cases where we do things in C. The major difference between C and C++ is what? What kind of language is C? Do you all know what that's called? Pardon? C is called an imperative language. You say do this, do this, do this, and you give it things and it does it. C++ is a slightly different language. Anybody know what kind of language C++ is? C++ is called an object-oriented language. Object-oriented language. Everything we've been doing up to this point in the semester has been C-like. It's been kind of like somewhere between C and C++. I refer to it as C++ because you just take the elements you need from C and C++ and you're happy. But most C++ code is written in what's called object-oriented style. What we're going to learn is a little bit about what object-oriented is, and we'll get into that. So let's move on. So this might look familiar to you since you just finished the project. In your last project, we were tracking a number of aspects about a number of different people, right? So what we ended up doing is depending on how you did your project, but this is how I did mine, we ended up with 5 vectors. One for first name, one for last name, one for age, one for gender, and one for a particular camp, right? 5 vectors. But when we wanted to get information about one particular individual, we had to go look out of this giant collection of information for all individuals, and just based on the place in the vector, go through and extract all 5 of those pieces if we wanted to work with it. Does that make sense? Look familiar? And if we wanted to have a function, oops, that got cut off a little bit. If we wanted to have a function to work on just one person, we still had to pass in information about everybody every single time, didn't we? Right? So when we passed in first, last, age, gender, camp, we were actually passing in giant vectors that could have information about thousands or hundreds of thousands of people just to work with one person potentially, right? If we were searching by name, we were really just trying to find that one person. How many of you all think that this seems a bit awkward, right? Here we are, we're trying to do things with just 1 or 2 people at a time, but we're passing around information about potentially hundreds of thousands of people. And this information about one person is scattered across a bunch of different vectors. The other thing about this, everybody see what I'm talking about here? How the data is just like not conveniently packaged together? The other thing about this is when we write a function using these 5 vectors, that function is very specific to the data, isn't it? Like it's not a function that just takes any 5 vectors. It expects the first vector to be a vector of first names. It expects the second vector to be a vector of last names, the third to be a vector of ints, and so on. So the function we have, even though it's just living out by its own and taking any data you get it, is very, very specific to the data we're passing it. Everybody with me so far? All right. What if I told you that there was an easier way? And the way we can do things is we can have just one blob, one object, what it's called, since we're doing object-oriented programming, and in that object we have all the information about one refugee packaged together. All right? So for this refugee, a particular refugee has a first name, a last name, an age, a gender, and a camp, and instead of being scattered everywhere across a whole bunch of vectors, it's in one nice convenient package. How many of y'all would like that? This week only, $19.99 plus shipping and handling, 3 extended easy payments? No. All right, so this is what an object is. An object is a way of packaging all the information together, even though it has different types, right? Are age and gender and camp all the same type of data? What is age, camp, gender, character, right? Before we saw vectors, and vectors allowed us to package things together as long as they were the same type. But now we have objects, and in the objects they are not the same type, right? They have data inside the objects that is not the same type. So we have different data things crammed in there. The cool thing about this is once we do this, we can actually take a bunch of refugees, because they will all be the same type, and put them into a vector. So our eventual goal, instead of having 5 vectors where everything's scattered around, we have one vector. Inside that vector is a bunch of refugees. Each refugee is just one individual, and it has in there the information about each individual. All right, does that sound cool? Does this make sense why you're doing this? All right, it's a lot easier for us to think about problems that match the real world than it is to think about where data is scattered everywhere. If we want to think about a refugee camp, then it's natural for us to have a refugee, right? It's natural for us to say, oh, when you're working with your refugee has these attributes. And if we want to have a whole bunch of them, we can join it together, and now we have a bunch, but each has their own attributes. Everybody with me so far? This is important, okay? Because this is the basis of everything we're doing. All right. The other thing, and this is where it gets a little crazy, all right? Because this is going to cause us to revisit kind of how information flows through the program and where things reside, is that when we have a function for a refugee, this function is only ever going to work on what? Is it going to work on ints or floats? It's going to work on refugees. So the other thing that we do, rather than keeping the refugees separate and the function separate, is we actually merge them together. Okay? Because whatever functions we have are only going to work with that particular type of data, we put the functions in with the data inside the object. Now when we do this, this is called a class. A class is what we're going to be doing when we build classes, is we're going to be approaching problems in a different way, so that we're going to have data that's relevant to the problem we're working on, and we're going to encapsulate that into a class. And we're going to have functions that are also encapsulated into the class as well. All right? Because there's no point in keeping them separate if they're only ever going to work on one thing. Does that make sense? If we have functions that are only ever going to work on refugees, we might as well include it in the class with the refugees, and then we'll always have it with us. All right. Conceptually, this is what we're going to be doing. Questions? Does it sort of make sense? And here, remember the 17 seconds rule? I'm actually going to wait for like 20 seconds for questions now. So I want to make sure everybody kind of conceptually sees where we're going. Yes, sir?
So if you have a vector of refugees,
Uh-huh.
each element will have a function refugee.
If we end up, yeah, I didn't draw the vector, but if we end up with a vector of refugees, each refugee will have functions. Every refugee will have the same functions because they're all part of they're going to be part of the same refugee class. But every refugee will have functions that allow us to do things with the data inside it. Yes? So the question was going through the logic, would this be the same like a string? And the answer is absolutely. We have been using classes throughout the semester, and we've been using objects, and I'll tell you the difference between object and class shortly. It's just terminology. We've been using these things throughout the semester without knowing about it. So the things that we have used that are objects in the past are string, vector, IF stream, OF stream, I don't know, other things. I mean, there are probably other ones that I'm forgetting, but these are things that are actually classes and objects that we've been using throughout the semester. And now we're going to learn to build our own, okay? And the thing about building our own is the ones we have are going to be very specific for our purpose. Okay? And they're going to contain everything we need to solve a particular problem. Other questions? Yes? Okay. Let me just tell you the difference between a class and an object. So we have classes, and the idea of class is it's a collection of data. It doesn't have to be homogeneous data type. It can be heterogeneous. Whew, that's a word I don't say often, clearly. Data types, because they can have any types that you want in there. And we're collecting all the data together, and we're collecting functions that are specific to that data in there as well. That is in. And the idea of a class is that the class is the blueprint. The class is the definition for how these things are going to be built, how we're going to bundle them together, what goes in there. Okay? So when I say class, you say blueprint. Ready? Class? So class is the blueprint for how we're going to build objects. An object is what you have when you actually build something from that class, or instantiate something is the fancy computer science language that allows you to get paid a lot more if you know that word. Okay. So when we instantiate something from a class, we have an object. So we might have a string class, but until we actually say string and give it a name in the program, and it gets built and instantiated, that's when it becomes an object. Okay? All right, everybody with me? A class is and an object is, and you instantiate a blueprint to get the thing. Okay, so that's what we have. Questions so far? Questions? Going once, going twice? All right, so here's what we're going to do. I'm going to go ahead and all right, so I wrote a little code here, and what we're going to do is just show you what a class looks like. Okay? This is just an example. It won't compile. It's going to be wrong. But I want to show you what a class looks like, and then what we'll do is we'll go through and we'll start writing some simple classes and seeing how they work. So, when you have a class, and this is going to be quite confusing to you, the first word you write is class. And that tells that you're building a class. Then you have a class name. And the class name is anything that's a valid C identifier, right? Like a, letter or underscore first, followed by letters, numbers, and underscores. Curly brackets. We have a closing curly bracket. And for some reason in C++, when you're done with the class definition, you have to have a semicolon after it. I don't know why. Inside the class, we're going to have a couple of different things. We're going to have something called public, and we're going to have something called private. And the idea behind public and private is that when you have an object, there will be some things that are internal to the object that only the object can see, and functions that only the object can call because they're not intended for outside use. And then you're going to have some public things that anybody can call to access the object. Now you might say to yourself, why do we have this separation of public and private? Anybody saying that to themselves? Okay, so why do we have this separation between public and private? Think about it this way. What we're trying to do when we define an object is we're trying to define something that works in a very controlled way. And what we want to make sure is that we are encapsulating all the functionality of our object and our class into just that. We don't want to have any external methods. And we want to have some control over how data gets into the object, how it gets out, and who can do what. Think of it this way. Imagine you are running a bank. Has anybody ever been to a bank? Right? What do they have at a bank that you might want? You said money. My little kids might say lollipops because they're still young and they have those there. But when you go in, you can't just walk in and it's not a room filled with money. Unless it is, in which case I want to know which bank you go to, right? It's not a room filled with money. There are very defined, controlled ways that you get your money, right? You go up to the window, you present ID, you either write a deposit slip and put it in, you write a check and you get it out, you prove that who you are with your card and they give you money, right? There's a very well-defined thing. Maybe the people who work behind the windows have access to things inside the bank that you don't, right? They can go to the vault and they can get money for you. They can do all sorts of other things. The idea in classes is that we're going to encapsulate the class so that other people who are using your code can't reach in and screw with it, right? Remember when we talked about global variables? Global variables are bad because they can get changed anywhere, and that causes problems. With classes, we're going to encapsulate data so that when we write the class, we can test it, and we can be sure that the only way that things are going to change is ways that we wanted it to change, and ways that we defined it to change. Okay, and we'll see some of this as we go along. Okay, so we'll see more about this going. Questions so far? Nope. All right, so for each of public and private, we can have what are called data members. We can either have public data members, or we can have public prototypes for public methods. Now remember when I was talking about classes, I said that we're going to put the function inside the class, right? When we have classes and we have functions inside them, we call methods. Method is a function that is inside a class. Why do we give it a different name? Because we get paid more, right? Because it actually makes it clear whether when you're calling something it belongs to the class or if it is a function. So we have public data members and prototypes for public methods. And then we have the same thing like this. We have private data members and prototypes for private methods. Pardon? Oh, I missed a T. All right, that's what we're covering in this class, public and private. There are a couple other things, and I'll just show it to you now, even though I'm not going to tell you what it does. You might see protected, and you get protected and protected. Our code doesn't use this, but as you go along, you might see instances where you have protected. So, all right. Public data is anybody can access that method. Anybody can access that data. Private means only the object itself can do it. And we'll see how this works. Questions so far? Sir? Yes, private means we're going to see what happens is that when we instantiate an object, we'll have an object. And when we're working inside that object, like the code that makes up that object and the object operates can call methods on itself, which is a little bit strange, but only it can call those methods. So other things cannot call them. So when we do something like string.at, do you remember doing string.at? String.at is the method. It's a public method. Anybody who has like a variable string x can say x.at, and then you're able to do that. If they're a private method, and then like it was like x.kill or delete or foo or something like that, if you said x.foo, if it was private, the compiler would say you can't do that. Can't do it from outside. And we'll see some examples of that as we go on.
So how would a private method get called? Would it only get called, like, let's say someone does a public method and the public method calls it? Or?
Exactly. So the only reason a private method would get called is if there was a call from some other method inside there, perhaps a public method. Now we're going to see as we go along, there are a couple of things about classes that are different, because there's a couple of methods that get called automatically, like just automatically all the time. And what these are is they are things that when the object is created, it's nice to have something that can like initialize all the values in the object. And so there's a thing called a constructor, and anytime you create an object, the constructor method runs automatically. You don't have to call it, it just runs. Do you know how strings are always initialized? We don't have to initialize strings, right? Like we do ints. It's because strings have a constructor and they get called automatically. And when we write ours, we will call them automatically. All right, other questions? Everybody with me conceptually, you think? It's confusing at first because it's a different way of thinking about how to structure your code. But what you're going to see is that when we actually write code, we're going to end up, instead of writing big chunks of code, we're going to end up writing a lot of small chunks of code. And we're going to be able to break down a particular problem into some very small steps, and each step is pretty small. Okay? I will say something. Programmers are what? I don't think I went over lazy, right? Object-oriented programming seems to go against the laziness principle. Right? We want to do as little work as possible to get the maximum results. There is this notion that sometimes it's worth putting a little effort up front if it'll save you effort down the line. So classes are an example of that. What we're going to do is we're going to spend more time writing some classes. That will be more work up front. But the idea is that once we've written the class and tested it, we have a usable chunk that we will never have to mess with again. Okay? So we'll put some effort into building up these small building blocks, and then we can build very complex things out of them. And we can test them, we can write them in pieces, and we can test them in small pieces. Yes? Yes, that's the other thing about them, is that the idea originally, one of the original ideas behind classes was what's called object reuse. If you write a good class for something, you can just, once the class is written and tested, you can bring it someplace else. For example, strings, vectors, right? Those are written and tested, we can use them over and over again. When we're working with them in our code in this class, we end up writing some very specific classes that solve particular problems. So you may or may not ever use those again, but it just depends where you're working. Yes?
So for just kind of going back to like conceptual understanding, so when we were talking about the string, like so when you call a string,
Yep.
there is a class that deals with that string, but
Yep.
when you call it, it becomes an object because it's
Yes.
instantiated.
Exactly.
And that's why you can access the constructor, which automatically.
Yes. So conceptually, we have this class, which is a blueprint. And the class for string will say literally class string in there, just like we wrote class name up there. And when you call it, the compiler looks at it and goes, oh, you're calling this class. I know how to build one of those. So it goes and it builds one. And it puts all the associated data types in there. It keeps track of all the functions. Okay? And it puts those in there too. It's got like at and length and all that stuff. And it builds one of these objects. And the object that's built has whatever name you gave it. If you said string name, now you have an object. Its name, sadly, is name, right? And then you can do name dot, and when you do dot, it refers to that particular object and calls things about it. Okay. Yes? Mm-hmm. We'll see that as we go along. So the analogy is the bank, right? Public is anything anybody can walk into the bank and do. Private is only what people who work in the bank behind the glass, the tellers, can do. And there's typically an interface between public and private, which is like analogous to passing things through the window, right? Does that make sense? So you can go in, public is like withdraw money, right? And the public method for bank would be give me some money, withdraw money, and you would go and give it to the teller, and the teller would take your request to withdraw money. It would verify your name, account, and ID, and then it would access the get money out of vault function. And the get money out of vault function would be private. Only things that are part of that bank can go get money out of the vault. Does that sort of make sense? It'll become clearer over the next like 5 to 10 years as you do this a lot more. So, I mean, this is hard not because I think it's inherently hard. This topic becomes hard because it's a transition away from what we've been doing. Okay? And we have to think now, instead of being able to access any data anytime we want, we have to actually think about how to build these classes and get data in and out of the classes. For Project 4, which I'm about halfway done writing, I'm actually defining the classes for you so that the amount of code you write is going to be small. You just have to figure out how to put it all together. Okay. And then for Project 5, well, let me just give you a hint. Project 4 is actually Project 3 over again, except now we're doing it with classes instead of vectors. Project 5 is going to be Project 4 over again, except now you're not allowed to use vectors, and you have to write your own vectors. What do you mean? I just heard little murmurs and what? It's cool. It's good stuff. All right. All right. Yes, sir.
So since a string or like a vector is a class,
Uh-huh.
could like we go into the vector class and like add things like search through the class?
Okay. So the question is, since string and vector are classes, could you go in and change the source code for them? And the answer is absolutely. If you could, like the way the code is distributed, like the way the compiler is, it's already kind of built in. But if you want, you can go online. You can find the code for G++. It's an open source compiler. You can download it. You can find all the code for like string.cc, and you can change it. It's there. It's for you to change. Now, not all the code in the world is made available that way, right? Like if you wrote the banking website code or the banking code, it's not like they just let you download it and change how it works. But for things like string and vector, that's just a public definition of how it works. You can do that. Okay. Yes? Uh-huh. Yep. All right. So the question I got is actually an incredibly astute question. So let's say we have two objects that are very, very similar. Let's say that we come up with an object for teacher and an object for student, right? Some of the stuff will be different. Like I have like the grading I have to do, and you have grades, and I have projects I have to write, and you have projects you have to do. But we might have like name, age, shoe size, hair color, stuff like that, all similar. So the question is when we have these objects that are somewhat related, can we reuse things? And the answer is absolutely. We're not going to get to it in this semester, but there is something called inheritance. And the idea of inheritance is that you can take something like a person object, and you can inherit from it, and you can turn it into a student object, you can turn it into a professor object, you can turn it into a policeman object. And what happens when you inherit is you inherit all the characteristics of person, age, name, height, shoe size, hair color, right? But then for student, you add some additional stuff. For student, you add some additional stuff. For professor, you add some additional stuff. Policeman. Yes. We're not getting to that this semester, but that is very good looking ahead. So, all right. Who's with me conceptually? Who's excited? Who's fearful? Who's both excited and fearful? All right. Let's take a 1-minute break because I've been talking for like 30 minutes now, and then we'll look at a real example of a class. All right, so we've been talking about person example, so let's use that as an example. All right, what we're going to do is we're going to develop a person class. This will be useful for us because conceptually to be similar to the refugee class as you go on through your next assignment. So let's take a look at this. When we define classes, we generally define them before int main. Okay, we define them before int main. Next semester, if you keep doing computer science, you will learn how to put a class in its own file, so that instead of having all your classes in one file, you have a separate file for each class, and you'll learn how to get the compiler to put them all together in one program. That makes it easier to reuse it. But for this semester, we're just going to put our classes inside one thing. All right, so a person might have some public and some private methods. And data, okay? So, what data about a person would you expect to be private? And by private means something that only that object can change. Yeah, so anything that is probably sure, Social Security. I'm going to do things like maybe a name, right? Right? You don't want people just changing your name on you randomly, do you? How many of you would like people to just change their name randomly? Nobody? How many are happy with your name? I'm happy to give, if you're unhappy with your name, I'll be happy to give you a new one. Okay. So, we're going to have string. I need to put pound include string up here. All right, so your name might be in there. Weight. Gender. All right, we'll just use character for that. Right. And we could go through and we could list a number of different things. Now, the other thing we want, let's just use these for right now, okay? The way that objects work, though, is we end up for, let's just think for a second. All right, just for fun, we're going to have a public mood, right? Now, can other people change your mood? They can, right? They can be mean to you. They can give you a hug and make you happy. I'm just going based on my 3-year-old, what makes him happy, right? Give you candy, make you happy. So your mood is public. The other thing that we're going to have is we're going to have a variety of methods that allow us to change some things. The first method we are going to have is called a constructor. And the method for a constructor is weird, okay? It's weird. And the reason a constructor is weird is that the constructor has exactly the same name as the class, and it has no return type. Every function that was seen throughout the semester has had a name, parameters, and a return type. Constructor does not have a return type. Anybody guess why it doesn't have a return type? Because it's actually returning whatever type of object it's part of. And so we just kind of, instead of saying like person, what it really doesn't have is like a name, because it's just a constructor. But it's really returning a person object. Okay. Now, this should be enough to get us started. Let's write a little bit of code that uses these things. All right. If I were to try and compile this code now, what we have is we have class person, public string mood, constructor person, string name, weight, and gender, right? If I were to try to compile this code, it may or may not compile. And let's just see if it does or not. Okay, it does compile right now. It just won't work yet. All right, so here's how we define a person. We say person, I'm just going to use my own name, Clay. All right. But it can be anything. This can be any identifier. It could be person X. What do you want it to be? Any preferences? Is X conceptually easy for you since we've been dealing with int X and stuff like that? Yes? Let's go with X, okay? Person X. So Now when we compile, let's see what happens. It worked last time, right? Now it died, and what it's complaining about is that there is no class person, okay? Because what we did in this prototype is we defined, this is the function prototype, and the compiler was happy with the prototype for the method, but once we actually created one of these objects, it went and tried to call this, and it couldn't find it. Anybody have any idea why it couldn't find it? Yeah. Because we haven't actually written the function yet. The way we write methods is like this. It starts with the name of the class and 2 colons. Person, colon, colon. So any method we write for the person class will say person, colon, colon. This lets the compiler know which class it belongs to. Then the actual name of the method and the parameters, if any. And now we have a function. What does this function actually do? What does this method do? Nothing. But it exists, and it's okay. The compiler is happy with things that don't do nothing as long as they exist. Okay? Yes? No, what happens inside the class is there's a prototype. Just like we had function prototypes before, the prototype goes inside the class. But when we actually write the method itself, it goes outside this semicolon. And you tell it that it actually belongs to the class by putting this, the name of the class, which is person in this case, with 2 colons, and then the name of the method. Okay? Does that make sense? Now, in general, we're going to write all these above int main. I believe you could actually put the function, the method implementations below if you wanted, but we'll just put them all above. Okay. We would name it whatever. Oh, no, because here we're actually dealing, the idea of us is with this person object, we are modeling a person. It's not going to be a very accurate or precise model, but it's going to be a model nonetheless. For every time when you're object-oriented programming, you will have objects that represent some concept most of the time. Like most of the time, you don't just put random things into a class. You do it because when you think about the problem, you say, well, in this case, we're dealing with people, so we're gonna put everything into a person class. If you're dealing with, like, if you wanted to write a card game, for example, you might have a class that's a card. A card might have a value in a suite. You might have a deck, and then the deck will have a whole bunch of cards in it. If you're playing blackjack at a casino, you might have a shoe, and a shoe will have multiple decks in it, right? And so we're going to functionally build a whole bunch of stuff out of these things, right? You might have a car class, and a car will have an engine and 4 wheels, but then you have a pickup truck, which you add a bed, or you might add, like I was in the military and had 6 Humvees that had rocket launchers mounted on top, so I might take my car class and add armor and rocket launchers, right? So when we build these classes, they're going to be conceptually related to what problem we're trying to solve. Everybody with me so far? All right, so here is our constructor. And what I'm going to do, and this is atypical. I'm going to have this constructor print out. So what we're going to see is that when we call this person X down here, this cout statement should happen. Most of the time, you don't have to have your constructors print out. I'm just doing it to show you 2 things. First, I want to show you that the constructor is actually called. And second, I want to show you that everything we've learned throughout the semester is still valid. Everything you've learned in terms of programming can go inside these methods as we do them. Yes?
Why is it automatically called? Is it just based on like
Okay, let me just demonstrate this first, and then we'll talk about why it happens. Okay? So everybody with me? Here's what we're going to see. Only thing our program does in main is declare one of these person objects. And what I want you to see is that the constructor gets called automatically when this happens. So when we run this program and we type /person, it should print out person constructor called. The idea behind this, the reason that the constructor gets called automatically, is so that you, as a programmer, have a chance when your object is created to set some default values and to do initialization. Does that make sense? Because there's oftentimes stuff that you want to do. So, for example, we might want to set some of these values. Okay. So let's say we wanted to set a default age, a default weight. So, for example, if we don't give a double initialized value, what value does it have automatically? How many of y'all think 0? How many of you think we have no idea what it's going to have? Yeah, this is one of our base data types. If we say double weight, it will have some random value. We'll have no idea what that is. Okay? How about a string? If we don't give initialize a string, what value does it have? Well, in this case, string has an empty value. And do you know why it has an empty value? Because the constructor in the string class sets it to empty. Okay? You don't have to. Yep. So you don't have to initialize string because the string class handles that. So what we can do down here is we can say weight equals 0. Right? And we can say gender equals space or something like that. Okay? And now what's going to happen is when our constructor is called, we will automatically be able to think. Oh, the other thing we can fix in here is mood. What mood are you all in? All right, so we can set our mood. Oops. Now, remember, this mood data type is public, while the other things are private. But inside the constructor that's working on the thing that got implemented, you can access either. All right, who's with me so far? Good? Who'd rather be set on fire than be in this class? No one? Nobody's ever taken me up on that. All right. Okay, so let's compile this and make sure it still compiles. We haven't done anything that's visible yet. All we've done is meddle with some internal settings. We haven't done it. So if we run it, we're still just going to get the person constructor called. But now let's start seeing what we can do. We've declared this person X. Now let's do something. Let's say cout x.mood. Now, what happens is when we call this, we say X. Oh, we're talking about this thing X. The dot is just like we've seen for every other method, right? When we're doing strings or vector, like dot at or dot length. And then mood, it goes, okay, you're referring to object X. X is of the person class. Dot mood, I will go look and see what mood is. Oh, it's a string right here that you're talking about. I will tell you what's in that string. So this whole thing, let's step through this again, right? X.mood, it goes object X. X is of type person. Person is a class. So I got to go look at the class definition to see what's going on in there, right? So when I say dot mood, it looks up here and it goes, okay, mood. I'm looking for something in the person class that's named mood. Anybody see anything? This string right here. So when you say X dot string, it says look inside this object X for the data member named mood and tell me what that is. What's this going to be? It's been initialized to happy, so this should print out happy. Okay? If it's working correctly. So we'll compile it. When we run it, it said person constructor called and happy. All right? Everybody with me so far? This should be similar to what we've seen before, right? With string dot, if we have a string dot add or a vector dot length or things like that. Now we're able to access the things that are inside there. Sir?
If we were to see out X,
Okay, so the question was, what happens if we just see out X? We get a compiler error. And the reason is because so far, oh, by the way, we get a huge compiler error. Like once we get into the classes, these compiler errors become insane. Okay? In fact, let's see how long that was. Yep. So it just generated 97 lines of errors for trying to print that out. Later, like next week or the week after, we will learn how to make our things print out nicely, but we haven't gotten there yet. Okay? So right now, The x.mood is a string. Do we know how to print out strings? We do. We're golden. All right. Everybody with me so far?
If you were to do one of the private ones, so like
Okay.
x.name, would it still access it as private?
So the question was, here we did x.mood, and mood was what? Public. What happens if we try to access one of the private things? How about that? How many of y'all think this is going to work? How many of y'all think it's not going to work? It's not going to work because this is private. Here, I'll show you. So what we've done is instead of printing out mood, now we're trying to print out weight. Mood was public, weight is private. And what it's going to say is literally, weight is a private member of person. You cannot access that directly. This is the same as going into the bank and saying, get money from vault. And there'll be a nice guard there who says, error, vault is private, right? You're not allowed in there. Okay. Everybody with me? You all happy so far? Okay. All right, so everybody's happy. Let's make everybody sad. How do we alter the mood of this person? X what? X.mood equals sad. So now what we're saying is, we're going to assign sad to whatever X.mood is. X means go find that person X, find the thing there named mood, and set it to sad. And I need a semicolon at the end. You all are better than the compiler. It's like pre-compiler. And now when we run it, we should see the person gets changed from happy to sad. All right, everybody with me? All right. And what happens if we try and change a person's weight? We cannot, right? We cannot change a person's weight because it's a private person. All right, now notice one thing that I wrote in this comment up here is that this is a public data item. Most of the time, objects do not have public data items. It is unusual for objects to have public data items. Most of the time, what's going to happen is they're going to have private data items, and we're going to define methods that allow us to access those. Okay? The only reason I really did a public data item here is for demonstration purposes, so that you could relate the idea that we had this thing in there to stuff you'd seen before. Right? Everybody good so far? All right, so let's look at how we actually really do things. Here's how we actually really normally do things. We normally write methods like this. Right? This is called an accessor. An observer. It's also called a getter. So an observer is something that lets you see the value of a private data member. Right? It lets you see the value of a private data member. They're called accessors, let you change them. Observers will let you see them. Other people call them setter and getter. So you can see it fine both ways. Okay, everybody good so far? Let's actually see how this works. We've defined this. This is a method. We know it's a method because it ends in parentheses. This means it's a method that takes no parameters. So when we write this, we actually have to go down, and just like we did before, we type person : to let the compiler know it belongs to the class. Then we say get name. Now, this actually has a return type, right? This is going to give us a string back, whereas the person class didn't have a return type. This does. So we have to put the return type in, and we say string. This is returning a string. It's a method that belongs to the person class, and it's named getName. And what do you think this tells us? Yep. So all we have to do is say return name. All right, I'm going to split the screen in two so I can show you the function prototype and, the method prototype and the method at the same time. So here's our observer method, our getter method. And here's the actual implementation of it, okay? It's got the same return type. This says it belongs to the person class. It's a method called getName, and it returns name. We just did scoping, so let me ask you a question. What name is it referring to? What name is it referring to? Sir. Okay. Yes. The only thing we have that's name is this private data member. We've talked about scope, but now that we have classes, we have one additional type of scope. And the scope is called class scope. Class scope. So when the compiler sees this name, it goes, hey, name. Is there a local variable named name? There is not. Is there a parameter named name? There is not. It goes, well, let's see. This is part of the person class. I can tell because there's this person : there. Let me go look in the person class and see if I see something called name. Just like it did for mood before, right? It's looking for something named name, and what does it find? The private data member named name. Sir? Yes. If that wasn't there, it would then, and there was a global constant or variable named name, it would use that instead. But, yep.
Can you have a public and a private data type with the same thing?
No, you cannot have a public and private data type with the same name. Say a data member. Yeah, because then the scope gets too confused. Yep, it gets too wacky. So, okay. All right. So it goes and it finds the name. So let's actually see what the person's name is. So we say cout angle x dot get name. All right. What is this person's name? What's it going to print out? It's going to be empty. So it should print out nothing, but we should see a blank line for it. And there's our blank line where the name should go. Well, that kind of sucks. That person doesn't have a name, do they? Should people have names? Does it make it easier? All right. How do we give this person a name then? Okay. So we have to assign a name somehow, and we have to make that name get into the private data member, don't we? Let me show you one way of doing that. One thing that we could do is we could actually, if we wanted, we could create a thing called set name, right? But how many of y'all think that you should be able to set your name publicly? Fred, right? We don't want to allow people to set a name, so it has to be something that's private. So let's write, I'm going to show you something. This is called an overloaded constructor. You can have different constructors for the same class, as long as they take different parameters. Okay? So this constructor has no return type and it takes no things. This constructor, and we can tell it's a constructor because it has exactly the same name as the class, takes a string. And what do you think this string is going to be? The name. Yep. So let me show you how we do this. I'm going to go back to, just one thing here. I'm going to rewrite this constructor. If I can type. And it takes a string new name. And in here we just say name equals new name. So this constructor gets called. It's passed a new name, and name becomes equal to new name. So when we call the constructor gets built, right? When we call the object, it calls the constructor, the object gets built, and if we passed in a name, that will be the object's name. So let me demonstrate this. We'll go down here to main. We're going to create another person. We'll call this person Y. And what we can do is right inside here, we can give person Y a name. Okay? You all look confused. Yes?
So it seems like we're just doing a lot of different step arounds to keep a variable private even though we want to be able to change it.
Bingo. So the question was, we seem to be doing a lot of work to keep a variable private even though we want to change it. Yep. You're absolutely right. But we only want to be able to change it in controlled circumstances, right? Like if the variable is the amount of money in the vault, right? You don't want people just walking in and taking all the money out of the vault. You want an interface to do that. The objects we're working with now are relatively simple. As we go on, they will become more and more complex. And as they become more complex, you want this protection. And what we're going to see is that one of the things you can do is that when you set these things is you can have error checks inside the object to make sure that the thing that's getting set makes sense. And you can encapsulate all that together. Okay. All right, so here we've created person named Fred. And let's just go ahead and see out y.getName. And what do you think this is going to print out? All right, let's compile it and see if that works. All right, so we run it. Our first person is happy and sad and has no name, and our second person says their name is Fred. Okay? And now, what we've done is when we created this person, we've given them a name. Yes? Okay, so the question is that we had one constructor that took no arguments and we had one constructor that took a string. We can never take another constructor that has only a string because the compiler has to be able to tell them apart. Even though they have the different name, they will have different parameters. Yes? Okay, so the question was, God, you all are on a roll today. You're getting like way ahead. All right, so the question was, if we do this constructor that has the name, does it actually do this implementation of the weight, gender, and mood? How many of y'all think it does? How many of y'all think it doesn't? Let's test it and see. We can test this pretty easily, right? Because we can just access the mood directly. So if we see out the mood of person Y, we'll be able to see what it was initialized to, won't we? Right? Everybody with me? See what I'm doing here? Right? So person X constructor, the constructor for person X had nothing, no arguments, and so it got called. The other one, we set the name, but the question is, does this other constructor get called automatically? And there seems to be, as far as we have controversy in this class, controversy because people actually raised their hands thinking it worked in different ways. We'll run it and see what happened. So here's what happened. Person X was happy, then they were sad. Person X had no name. Then person Y was named Fred, but they had no mood. Why did they have no mood? Because the other constructor did not get called. Let me ask you a question. How would we fix this? How would we make these other things? We would just call the other constructor. We could just do this. This is confusing, isn't it? Because here's what's happening, okay? I'm going to actually add a C out here, even though it's atypical. What's going to happen is it's going to change the name, then it's going to call this other constructor. All right. Oh, out. That seems better. All right, then it's going to call this other one. So here's what we're going to see. For the first person, we're going to see person constructor called. We'll see the mood change, right? We'll see the person constructor called. We'll see them happy. We'll change the mood to be sad. We'll see their name is blank. We'll call the second person with Fred. We'll get their name, and then we'll get their mood. And if this works, their mood should be happy. Okay? How many of y'all think it's going to work? How many of y'all think I'm laying some sort of evil trap because I do that from time to time? Some of you are on a roll today, and some of you are not. So, what? Man. All right, this is what I get for just winging it as I go along. All right. Well, class is over. I'll see you next time. Why didn't that work? Yep, the method for getName is right here. New name is just the name of the parameter that we passed in up here. Anyway, I'm not sure why this doesn't work, but I'll look and we'll figure it out next time. Okay, one last thing I want to tell you. Classes are covered in chapter 9 of the textbook. Please read chapter 9 of your book before we come to class next time, okay? This stuff is confusing, and I cover it the way I do, and it might be helpful to get a second view on it before you come to class, all right? And I'll figure out why this isn't working, because it should.